I'm Darryl D'Souza, CEO of HCUC, and I'm delighted that you've joined us to celebrate the national launch of the Institutes of Technology. As part of the celebrations today, we will showcase our student work, state-of-the-art equipment, and share with you our lecturers and one of our students who are paving the way to encourage more women into STEM. The national launch of the first wave of 12 IoTs aims to raise awareness and credibility of these innovative institutions, both locally and nationally, among key stakeholders and the public. Offering higher technical education and training, IoTs are the pinnacle of technical training, and the collaboration between employers, further education colleges, and university plays a pivotal role in delivering these technical skills employers need to thrive and to create secure, high-quality roles. They are also providing upskilling and reskilling opportunities for adults, helping to fill local skills gaps and building the foundations for future prosperity in an area. At West London IoT, we focus on construction, digital and engineering courses at level 4 and 5, as well as level 6 top-up degrees and flexible HN Flex CPD options, as we call them. Alongside Brunel University London and our anchor employer partners, Fujitsu, Heathrow, and West London Business, we aim to design courses that will provide our students with the skills needed in industry and that provide the talent needed to ensure we can build back better after the pandemic. It was a pleasure to welcome the Secretary of State, Gavin Williamson, in person to the West London Institute of Technology earlier today. We had a chance to see the developing facilities we have here, meet our learners and apprentices, as well as our specialist staff teams, as well as benefiting from a very useful roundtable discussion with our partner employers. So now we're going to watch an address kindly sent to us by Boris Johnson, MP for Uxbridge and South Ruislip, and Prime Minister. And then that's followed by a short video also from Gavin Williamson, Secretary of State of Education.
As a West London MP, I've seen how the West London Institute of Technology plays a vital role in getting young people to have the skills that we need for the 21st century industrial revolutions, equipping them with skills in digital, in engineering, in technology, in construction of all kinds. And I urge businesses, companies to get involved with West London Institute of Technology because they are providing the vital digital pipeline of skills that we're going to need to build back better.
Institutes of Technology, or IoTs for short, are one of the most exciting new developments in education today. Let me show you why. IoTs are collaborations between colleges, universities and local employers, all working together to deliver high-quality technical education and apprenticeships in areas like engineering, digital and construction. They put employer needs at the heart of the curriculum and provide students with access to world-class courses and cutting-edge facilities. Let's see an IoT in action. Over to Weston College, part of the West of England Institute of Technology.
So this room is called the virtual classroom, and it allows the teachers to teach in this space to learners who are remote. It's great cutting-edge technology that we're lucky to have through the Institute of Technology.
The benefits for myself with an IoT is that we have great links and connections with local employers. So we have good working relationships with Rolls-Royce, Airbus, GKN. By developing and nurturing the relationship with them, we can integrate what they're looking for their future employees and make that work within our own framework.
Here at Weston College we've got the further education side and we also have the university foundation degree courses. The technology in the room helps us as teachers to really look at making it more real for them. It gives them a chance to explore safely. The technology is there to create those scenarios in a safe way. As lecturers and teachers, so it's that link between theory and practice really. We can bring that together and it makes it more fun. You know, it's a lot more interesting.
By working collaboratively across a region, IoTs can reach out to more people, helping them get the skills they need to secure rewarding careers, and ensuring employers get the talented workforces that they need. And IoTs are not just for young people. They're for anyone looking to retrain or expand their skills. These unique centres of collaboration are a real game changer for employers, for teachers and learners across the country. The first institutes of technology are already open, with more to follow over the coming years. So please, watch this space.
Over to Neil Brayshaw, who will speak about the benefits of West London IoT and future scanning for West London and the London region. Over to you, Neil.
Thank you, Daryl. So the West London region is the UK's second largest economic powerhouse, and pre-COVID, it was a £73 billion economy with over 120,000 businesses. Now, data has highlighted a lack of level 4 and 5 technical skills provision, and this is holding back economic growth, hence why the West London IoT was established. With a focus on digital construction, engineering and health to meet the skills gaps for the West London region, the West London IoT was opened in August 2019. It was approved by the DFE and is one of 12 IoTs across England, with a brief to serve the West London sub-region and more widely the London LEP area and also across into the Thames Valley. The West London IoT has the full support of the Prime Minister, the Mayor of London and the Greater London Authority to help meet future needs in higher technical skills for the London economy. Now, over the last 2 years, we have been having extensive employer dialogue towards getting our delivery model right by offering a variety of models, including part-time, full-time, HNC and D, apprenticeships, and the opportunities to progress on to level 6 with our partner University Brunel. We are working with new employees and new employers to upskill existing workforces and to provide a channel and a pipeline into our local employer and organisations to meet these higher valuable, higher level technical skills. We are currently experiencing an unprecedented level of change in the economy, and that we are being constantly at risk from cyber attacks to an accelerated need for advanced digitalisation in order for us to stay competitive, to climate change and a significant shift towards a more greener economy, which means that our curriculum must be fluid and have the ability to shift as well in the way that we create and shape lifelong learning and the way that our culture is developing. We aim to build working and long-lasting relationships with our West London employers. And our West London employers are at the heart of everything that we do as a IoT. They help shape and inform our curriculum planning and work with us on meeting our delivery needs in both local, regional and national priorities. Working together in partnership with further and higher education, we aim to meet the vision of their organisations and their stakeholders and help achieve the ability to raise awareness of these sector skills priorities to the young people and people that need to retrain for these skills moving forward. Thank you. Our next slide will showcase the current students' work that we're doing in the IoT. I will now hand you over to Neil.
Hi, my name is Neil Benjamin Miller. I'm Head of School of Engineering, Technology and Innovation. And what I will talk to you about is one aspect which will be put into the chat room, and that's where our students and our tutors basically used a Matterport camera, which is a 3D laser scanner, which effectively they went around the building and they scanned the building and they created a virtual doll's house, as well as a 3D model and 2D model. So in your free time, you'll be able to look through a virtual tour of the building. In terms of the courses that we deliver civil engineering, building services, heating and ventilation, and construction management from level 4 to level 5. And the companies that we work with is Michael Longstyle and Morgan Sindall. So again, have a look, and it'll be a great opportunity to see what our students are currently doing.
The next slide shows our current IoT students, highlighting what their IoT moment or celebration has been so far.
Hello, my name is Nathan Sharp. I'm studying at West London Institute of Technology. I am in the Higher National Diploma of Mechanical Engineering for this academic year ending in 2021. I would probably say my highlight moment of the year would be the research project whereby we are testing the strain of a human femur during the gait cycle. So that would be everyday motion such as walking. My other highlight on top of that would also be virtual engineering. So that would be the involvement of software, which is also involved in our project. That would involve using a CT scan of a human femur, which would then be sliced, or should I say manipulated, to be simulated in a simpler form. And then it would be transferred over to Ansys, where it would be tested in boundary conditions. And special mention would also go out to the lecturers here. So my background is I've been in a working environment for 10 years, and then I've come back into education. Very difficult circumstances, especially being out of the education system. But the lecturers have been absolutely fantastic. So as well as helping in lesson, they've also been very productive and assisted me outside of lessons. So a big mention to them. So I would say if anyone is thinking about going into mechanical engineering, come to West London IoT.
Wahid Rodriguez. I study mechanical engineering high national diploma at West London IoT. For this year was coming into college and using the compression testing machine where we testing materials.
Hello, my name is Arpreet Singh. I'm studying in the West London Institute of Technology, Mechanical Engineering. And my highlight moment for this year it was like for two subjects, virtual and a research project. Because in these two subjects I used a different program for 3D designing. Because I like the designing.
Hi, I'm Jim Bishop, studying here at the IoT, doing a HNC in Electrical and Electronic Engineering. I've really enjoyed my time here, and some of the highlights have been actually getting in the lab and doing some practical experimentation with electronic components and taking measurements and sort of comparing those on simulation.
Hello, my name is Mahim Baig. I'm studying Electrical and Electronics H&D. My IoT moment would be probably generating simulations and doing practicals based on them, and you need to do calculations in order to generate those simulations. I really enjoyed that, and I feel like it gives us a lot of practical knowledge, this H&D, and it's going to be very important in the industry.
Hi, I'm Max Lucas. I'm studying at HNC in Electronic Engineering at the IoT, and I would say that my highlight is the interaction with the teachers, as there was great communication, and if we had any follow-ups on any assignments or anything, they were straight there to help. I previously struggled with this on my BTEC. And I didn't have the communication I required to progress easily, and I got suggested this college by a fellow friend who was doing mechanical engineering, and I definitely agree with their statement, and the communication through the teachers is a great aspect of this college.
I would now hand you over to Patrick, who will introduce the next slide.
Hello there, my name is Patrick Vernon. I am the head of School of Computing and IT. The school offers programs at level 3, including our T level in digital production, design and development, and level 4 and 5 programs in computing, cybersecurity, and digital games programming. Our anchor employers, Heathrow and Fujitsu, have been instrumental in developing project work and working with learners to enhance the learner experience. And now we're going to run a short video, which will give you a bit of a feel for some of the work produced by learners on some of our games development programs.
So I wanted to give the level a kind of story, and I wanted the story to be that this catacomb was taken over by a group of bandits, and they sort of use it to store a bunch of barrels full of some sort of illegal like liquids, and I wanted that to be sort of a hidden story throughout the level, which is why there's a bunch of barrels lying around and they're just sort of stacked. This was just a design choice. Made it seem less just like a catacomb and more, you know, something more for the player. I then decided to add areas in the map where the player couldn't reach. This gives a sense of like exploration where they can't go, but also showing detail of what's beyond that point. So it allows the player to see that there's depth to the catacomb or to the level, even though they can't reach it.
Actual gameplay with sound. I have probably learned quite a lot about the interaction between different things and how to make sets happen. The end game, it looks very cohesive. I'm very proud of it, and I like the fact that the only competitiveness is based on the points. If you're bad at the game, who cares? You've still got to play all of it. You just have a bad score. You can be competitive if you really want. Another part I'm proud of, the mine places aren't actually tied to a path. That is 100% script. More examples of sub-counters and flags just ruling this entire game.
I will now hand over to Maruf, who will introduce the next slide.
My name is Maruf Tungekar. I'm head of school for electrical, electronic and mechanical engineering. We offer a range of courses, both full and part-time, in level 3, HNC and HND in electrical, electronic, mechanical engineering and general engineering. We work with various employers, including MTC and Martin Baker Aircraft Limited, and we also offer courses top of degree with Brunel University.
So the project incorporates the FEMA in a custom-made jig, which is currently held within this compression testing machine. This is a Tinius Olsen 150 ST, and it can mimic tension and compression to a predetermined force. This is our independent project in relation to the strain analysis of the femur bone during the gait cycle. So essentially the gait cycle is how an everyday person would walk. There are several main phases of the gait cycle. So with this femur, it's an artificial femur in which we have clamped into a custom-made jig. So this jig here has been printed on site at West London IoT using a 3D printer, and it's took about 2 weeks worth of designing and printing in total. And what this machine is doing, this is a compression tester. This is currently mimicking the forces experienced during the gait cycle. So it is currently oscillating between 3,000 newtons and 500 newtons, in which this machine will take those readings and transfer them over to the Horizon software, and it will record graphically the mapping of the forces experienced. Determined force is governed by this software, which is Horizon software. This is directly communicating forces to the compression testing machine, and there are two graphs which represent the force against the position and force against the time frame allowed within the software. This is an impact testing machine. It will measure the energy dissipated through the material, which will be governed by this hammer. We've got a few samples here. We have brass, aluminium and steel, and I'm going to demonstrate how this machine works with a brass sample. So the brass sample will have a cut V groove, and that will slot in a specific place between the jaws, which are situated down there. So here we have two readings. So the first reading is 408 joules, which is an energy unit, and that is contained within the hammer setup. As the hammer swung down, it hit the sample, and the sample consumed the second reading, which is 10.6 joules of energy. We can then use this information and alter the temperature to create a DBTT graph. So this will be a ductile, brittle, transition and temperature graph. So we can either warm the sample up to above room temperature, or we can use liquid nitrogen to lower the temperature. Overall, this machine records the energy absorption, which can be used in the real world, for example, like a high-speed crash, such as car bumpers, which are subject to high strain. Particularly useful when high fracture mechanics are experienced, so that will be in the ship sector due to temperature variations of the sea. Can also be used for materials for airplane technology.
The hardness testing machine, which is used to find the resistance of the surface of a material. There's three types of tests that can be performed using this machine, which is Vickers, Brinell and the Rockwell test. Each of the test types are different because they have different intenders.
As you can see, it has a ball shape, and here we can see the value for the Brinell testing. It's HB 2.5, 187.5 for this part. And if we are going to move in a different place, it's gonna change, because it depends if the material is clean, if has any deformation, any other issue, or
Hi, I'm Jim Bishop. I'm here at the IoT. Today we're experimenting with the model of a compound wound shunt motor. Here we have our DC power supply set at 220 volts, and this is our rig with our voltmeter and ammeter, and our resistance is set in series, and we have a readout of the speed of the motor and the torque, and we can control the speed of the motor through our variable resistor. So I can switch the motor on to run, so it goes to start up. Here we can see the speed setting of the motor, which we can control with our variable resistor. If I increase the resistance, we should see the speed of the motor slowing. Here we have our armature voltage and our armature current. And And here we have a multimeter setting series with the motor to read our actual output current. You can see as I decrease the resistance, the speed of the motor increases. This allows us to take readings and then calculate our actual power output and torque of the motor. So we see these sort of machines commonly in industry, for example in silos for mixing machines, anything that requires DC shunt motors, AC units and various other motors.
Hi, I'm Max Lucas. I'm studying at HNC in electronic engineering at the IoT, and today we'll be looking at a three-phase power induction motor. And here we have a three-phase power inlet, and we can turn this on and off here. There is also a safety strip, so if any of the cables are moved about, this will protect the user, and it's limited at 30 milliamps, so there's no safety concerns. Then we have some more connections here, just feeding the power further down the circuit. Then we are able to vary the frequency of this motor by having a rheostat connected in a star formation. And there are ways that you can change the frequency of the motor by adjusting some of the options in here, which we'll go into later. Then we have the motor connected in a delta star formation with these cables going into the motor down here. And here we'll be able to see the power factor of the motor and whether it is capacitive or inductive. So when I turn the motor on, flicking the switch down here, we'll see the startup phase where it's building up the power, building up the torque, and we'll see it will stabilise at the power factor rating, which is written down here as 0.78. This means how efficient the motor is running, and so if we have a power of 1 coming in, we're going to get 0.78 coming out, and the rest is lost through things like heat energy. And then we are able to vary the power up phase by changing the rheostat. And now we should see a much quicker power up phase. Not like that one. Change one on. Now it should power up much quicker, and so it stabilises immediately. This is because this is due to a higher torque build-up, and we will now be running at higher frequency. We are also able to change the rotation or orientation of this device by changing the angle of the delta, and this will turn off, and now we were in anti-clockwise, and now we are operating in a clockwise motion. And that is about it. The uses in industry is generally used in high power uses where we should be able to change the frequency, as the other main motor of this variant is called a squirrel cage, and this is very difficult to change the frequency, but it's very efficient to run. This has more variance, so if there are options which need to be changed on a regular basis, this is the much better motor to use.
Hi, I'm Mahim Beg. I'm studying H&D in Electrical and Electronics Engineering. This is a standalone wind power experiment with AC and DC loads. Over here we have the motor, which is simulating the wind. Here is our wind turbine. Here we have DC to AC converter. And over here we have DC lamps and AC lamps.
I will now hand over to Judith.
Hello, my name is Judith O'Neill, and I'm one of the curriculum directors here at HCUC, and I'm responsible for many of the curriculum areas that you've just been seeing in the videos and from the heads of school. One of the big ambitions of the West London IoT is to try and get more women generally across involved in STEM subjects, so that's science, technology, engineering and maths, and we're really keen to get more women involved. Career pathways are really changing, as you're seeing, in engineering, in digital. It's not all about sort of really messy stuff. There's a lot of areas that the women are going to be attracted to that are going to help and benefit humankind. We do have female students right across all of our engineering, digital, science disciplines, but we would like to have far more, for more of you, for more of them. And indeed, we have many female staff teaching on the subjects. And so now we've got a couple of videos to show you of one of our students and a couple of our female staff telling you about their journey into the STEM subjects. So we can play the first video.
My name is ZEENAT and I'm Higher Education Program Leader for Engineering. It will be wrong if I say I was born with a passion of engineering. No, I was not. I was encouraged by my father to look into this subject, as I was unsure which career paths to take really, just like any other teenager. But having said that, it's a decision I don't regret taking, and I thoroughly enjoyed every moment and every day of my career in engineering. Naturally, being a curious child I always wanted to know how things operate. And you know, engineering fed my curiosity, because no 2 days are the same and no 2 projects are the same. After 12 years, I still find myself learning new things every day. I do understand it's not everyone's choice of subject, especially for females, as the sector is known for being male dominated. But I can tell you, it would not be complete without a woman touch, just like any other thing in this world. As challenging as it seems, it's not so difficult. And the living proof is our girls in engineering. They have always performed exceptionally well. So my message to any aspiring and the future engineers or scientists, I would definitely encourage you to look into this career. I mean, you never know, you could be next Sarah Gilbert or Sally Wright. Today's engineering is very advanced. It's not just about the bolts and spanners, girls. In advanced world of engineering, you can sit behind your desk and design a smart city. Lastly, I would just encourage all you girls to look into this field, as it's very satisfying and rewarding. I hope to see you soon on open days where you can ask me more questions about engineering. Until then, take care, bye.
Hello, my name is Catherine Quinn and I'm the Head of School for Science, IT and Media. I wish I could tell you that I wanted to be a scientist from an early age, but quite honestly, I didn't. I think a part of that was that I didn't see myself in science. I think when most people imagine what a scientist is, they picture your classic icons such as Einstein or Darwin. Typically, you're kind of white, middle-aged, middle-class men. And when I was a young girl, I just didn't see myself in that role. So quite honestly, I think my love for science grew when I went to secondary school, which I think most people would agree is quite a tumultuous time for most. You're struggling with your identity and who you are, and I took a lot of comfort in the world of science fiction. So I would disappear into the world of science fiction, and I think I took a lot of comfort in the idea that it was easier for me to be an alien from Krypton than it was for me to accept that maybe I was just a bit of an oddball from Watford. So science fiction, comic books, that became my love, and what I found then was that at the root of all of these stories was science at the core. So understanding the physics behind the TARDIS and the Doctor Who's control of the space-time continuum, or understanding how mutations occurred when Bruce Banner had an experimental accident. Science was at the root of all of those stories. So I fell in love with it and I pursued it, and I actually found that as I went higher up through science and I went through my degree in biomedical science and my master's in molecular biology, I I found that actually the real villains, I suppose, in the world that we face are things like cancer, cystic fibrosis, Huntington's, Parkinson's. These were the real horrors that we were having to face. And science, for me, was the hero in that story. It was the answer for the development of certain medicines that can cure us, for biomedical equipment to help us survive in a really quite horrific and scary world. I think that can be quite a daunting thought for most females in science, engineering or maths. I think there is a real lack of leadership and management represented by females. I think for myself it was a decision that I really struggled with. So although I knew I was driven and I was passionate and I wanted to progress, there was this fear that I didn't quite fit the managerial role. And a typical scientist, I would do my research, I'd read papers, I'd attend webinars on what would make a successful manager, and honestly I didn't really identify with some of those characteristics. For me they seemed very much authoritative, domineering type characteristics which just didn't fit me. And I will never forget when I took over a role as a section manager, one of the criticisms I had in one of my early meetings was, "Catherine, you're being too sensitive." And I remember being mortified in that meeting, and I felt embarrassed and I felt insecure and I doubted my ability to manage and to lead. And then I went away and I carried on and I worked hard, and I actually found later on that criticism of being sensitive, or that negative connotation towards being sensitive, was actually my greatest skill and was what made me the greatest manager, was that I could be sensitive and I could empathise with my staff members and I could be compassionate and empathise with them. So I suppose my message is to those women who are currently in science or in engineering and maths, to not be afraid to go for those leadership roles, go for those promotions, because your feminine qualities, the ones that we often are criticised for or feel insecure about, are the ones that make you a fantastic leader. My message to you, future scientists, is to not be afraid if you don't quite fit the mould. If you're not that classic grey-haired, crazy scientist, that's okay. Because the beauty about science is that it's for everyone. Everyone can do science. We are science. Living, breathing, physiologically, anatomically, we're all science.
It's Mohin Baig. I've studied HNC and HND in electrical and electronics engineering. This is my final year. I used to watch a lot of sci-fi movies when I was growing up, and a lot of things intrigued me, and I was very curious about the world. I really wanted to know, how do computers work, how do our smartphones work, and how do these vehicles work, and how is this power all generated? This is why I picked electrical and electronics engineering. As soon as I finished my HND this year, I plan on doing a top-up year in a university, and after that I may choose to progress onto various courses. I could do either electronics or electrical, but I'm going to pick electronics because I find little gadgets really intriguing. Women in engineering do have a lack of representation, but there's a lot of job opportunities for us, and I feel like women in engineering can inspire other women to join as well, and maybe we can make the world a better place and maybe advance the civilization.
Here at the West London IoT, we're working hard to meet the local and national skills needs around level 4, 5 and 6 technical skills. And a significant area of that is around apprenticeships. Apprenticeships aren't just at level 2 and 3, despite the common misconception. They are also higher apprenticeships and degree apprenticeships, and these are now commonplace within the sector. Higher degree apprenticeships are based around HNC, HND model, and an example of what we have at the West London Institute of Technology is that we have an electrical route, which we've now worked closely with Brunel University on creating a pathway into a top-up degree apprenticeship in the electrical electronics sector. This has been co-designed and co-created over a number of years with colleagues from the college, West London IoT, and also Brunel. And this has managed to create a pathway from our HNC learners who are studying on an apprenticeship route into a full degree apprenticeship. And this is groundbreaking for the sector. The advantage of this and studying a degree in this way is that you can be employed, you are given time off to study, and you can earn a very good salary at the same time. So a very different route from the traditional full-time degree program where you would study over 3 years and incur a significant amount of debt during this time. So I would encourage any young person to take this route. This also enables you to work for a company that wants to upskill you, to invest in you, and to give you fantastic job and promotion opportunities moving forward. The HN Flex model that we are also currently providing is an excellent opportunity to provide learners to study at higher levels in a more flexible and modular way. You can study and pick and choose specific modules over periods of time and not be constrained to a traditional academic year or to complete within a certain time schedule. So this allows for greater flexibility if you're in full-time employment and working around a busy schedule, which is very commonplace in this day. The benefits of employer partnerships that West London IoT can support employers means that we can work closely with you in securing and competing for the best young talent or talent for your business and giving you early access to employers and employees. We can help shape and develop your curriculum to align with your business needs and also create specialist pathways to develop the skills that traditional education routes seem unable to deliver. We can create a bespoke program to cater for your individual needs by upskilling our existing study program students and tailoring a pathway to make our learners oven ready for your organization. It allows us, by working with partners, is to have access to resources and specialist kit and equipment to work alongside SMEs as well as large organizations and prepare our IoT students in a real life environment to test our ideas and future opportunities with reduced risk. We're also looking at developing technical fellows route where we would second industry specialists to work alongside our full-time staff in supporting and sharing their expertise in the next generation of young talent. We're also looking to increase our collaboration with employers by co-designing and co-creating our curriculum offer. It will enable us to be in a stronger position to not only identify the skills needs, but to ensure that our curriculum is aligned to meet these specific requirements. Very much a partnership approach to delivery through work experience, masterclasses, and guest speakers. And of course, the donation of sponsored equipment is always helpful. To add critical exposure to specialist aspects of future careers within the sector, employers will aid the skills and behaviour development of our students, so it adequately prepares them for future careers. We can also provide the wraparound skills such as problem solving, using initiative, improving communication, boosting confidence, and setting out professional standards and expectations about working in the industry. We can also develop English and maths and digital IT skills in a contextualized way. This will enable preparing young people for the new hybrid way employers will want their staff to work in. We also have the ability to brand and tailor pathways with employers, and as I say, create a pipeline into their workforce. The West London IoT staff will also benefit in terms of upskilling on industry and relevant kit and equipment, and providing themselves with CPD updates and training from current industry specialists, and also keeping their skills and knowledge current and up to date with the fast moving sectors we are working alongside. We also have the benefit of being able to deliver and train with specialist kit off-site, so working on location with employers. These, I feel, are fundamental to the training and development needs of the young people in the IoT. And I'd just like to thank our key employers that have enabled the West London IoT to establish ourselves in this strong position. So thank you from Fujitsu, Heathrow, Brunel, West London Business, who are our key anchor employers, and also key contributors to the West London IoT, Morgan Sindall, Balfour Beatty, Atkins, HS2, Thames Water, JISC, Flannery Plant, GMB, Version 1, and Martin Baker, to name but a few. We want to grow, and we are always looking for additional partners. Thank you. I think this is an opportunity now for some questions.
We've just had a message through to the chat. One of our guests thanking us for inviting them and found it very informative and extremely useful. So thank you for that. And again, microphones are free now. So if there is anything you would like to ask, you can unmute yourself and use that format as well as the chat box. Presentations for our women in STEM. We've had a comment there. Thank you for that. That they were brilliant. So thank you. We'll definitely pass that on to our staff and students. And one of the other things we're looking at in terms of encouraging women in STEM is to look at how we can work with schools a little bit more closely and encouraging women to think about those science, technology, engineering and maths routes at an earlier age, and then bring them through and obviously encouraging them into the programs that we have at both Harrow and Uxbridge College, and then again into the IoT for that higher level skills. So that's again something that we're very much looking at. So if anybody has any links or wants to share any information with us on helping with that, then that would also be very welcome. Thank you.
Thanks, Lucy. I'm just going to add, thanks everybody for being here today. I think that was a fascinating viewing, and it shows really what the potential of the West London Institute and Institute of Technology in general have. What I was wanting to say is that I think we did have the Secretary of State in earlier, and one of the things we conveyed to him was the strength of the collaborative relationships in the West London region, and that goes for the colleges and the universities and indeed training providers and the employers in the region. Certainly we know that West London has had probably a disproportional adverse impact as a result of the pandemic, and so all hands to the pump really to get this recovery on its way, and that we see the West London IoT as being central to that, and certainly the government's looking at ways in which funding pots, etc., come together to assist this work. We're very much be looking to reach out to partners in order to bring forward such collaborative opportunities. So look out for that, all those who are in the chat, and obviously we'll get that message out much more widely.
So I'd like to echo what Darryl said, and thank you very much for joining us today. Thank you. Bye-bye.
Many thanks all. Bye.